Alrighty, so here we go, lesson 3.7. This is for Wednesday. We're going to cover this today and tomorrow. Friday and Monday we will review this chapter with your test coming up Tuesday next week. So let's quick refresher on absolute value equations. So how do we do an absolute value equation? What's the first step? And then you solve them just like normal. Add 8 to both sides. Done. Why do I bring that up? Because now instead of solving them, we are going to be graphing them. Copy. So absolute value equations. This is what your absolute value equations always look like. They're always in this V shape. There's a lot of things we can do to affect the V. A couple of things you need to know. One, this point right here where it changes direction is called the vertex. Okay. Couple other things. The domain of this function is all real numbers because I can have any x in here. You see it's going on forever and ever and ever in this direction. It goes all the way this way, all the way this way. So all the x's are represented. The range is greater than 0 because the bottommost value, remember range is up and down is the outputs. The bottommost value is here, but it will go up all the way because those lines will go on forever. So the range is greater than or equal to 0, okay? So you'll need to be able to recognize domain and range in all of these graphs, and the vertex is going to be very important for us because that's where it changes direction. So let's graph. So this says so if you don't know how to graph something, the first thing you do is kind of chart it out. X and G of X, pick a number. 0 is a great number. Absolute value plus 3 is 3. Pick another number. 1. If I plug in 1, absolute value of 1 is 1 plus 3 is 4. So let's take a look at what's going on over here. Before I graph this, I want you flipping back and thinking about this, okay? So notice we got a slope. It's going up 1, right 1 every time. This is just doing the exact opposite. So I'm going to be bringing this back a lot. I want to graph the original function first. Up 1, right 1, up 1, right 1, up 1, right 1. So the original function looks like that. That is plain absolute value of x. Now let's focus on this one, G here. 0, 3. So let's right 0, up 3. 1, 4. Right 1, up 4. So you see, if I plug in 2, absolute value of 2 is 2, plus 3 is 5, 2, 5. I've got that same up 1, right 1, the same slope. Okay, up 1, right 1 on the original, up 1, right 1 on this one, but I haven't found that vertex yet. So let's plug in another number. Absolute value of negative 1 is 1. 1 plus 3 is 4. So if I have negative 1, I'm up 4. And I found my vertex. I found where it changes direction. Once you know where it changes direction, it's going to continue that same slope going the opposite direction. So that is absolute value of x plus 3. How does the original compare with this function? How do they compare? Good. A couple of other things. The vertex here, 0, 0. The vertex here, 0, 3. Okay, it goes along with that other thing we talked about. It's gone up 3. A couple of other things here. Let's look at the domain. Domain of the blue one. We already talked about this one. Blue one. It's going to cover all the x's, so the domain is still all reals. What's the range? Well, the bottommost value is 3. Again, we're on the range here. The bottommost value 3. It's 3 and up, so y is greater than or equal to 3. Domain and range, vertex, and we notice it's been shifted up 3. That number out there is going to affect your graph. Very simple, a very direct relationship. It's called up 3. Okay? The whole thing is shifted up 3. Let's do another one. What's different about the numbers? So let's plug and chug again. I'm putting the original one on here so we can talk about the comparison. Put that on your graph right now. So here we go. Put in 0. If I put in 0, 0 minus 2 is negative 2. Absolute value of that is positive 2. So I have 0, positive 2. Don't get too ahead of yourself. Plug in 1. 1 minus 2 is negative 1. Absolute value of negative 1 is positive 1. So now I'm here. Do it again. Plug in 2. 2 minus 0, 2 is 0. Absolute value is 0. So now I'm going this way. Still haven't found my vertex, so I got to keep going. Plug in 3. 3 minus 2 is 1. Absolute value is 1. 3, 1. And now I've found my vertex. So, the vertex here is 0, 0. That's the original. Vertex here is 2, 0. How did this number affect the graph? Which way did it move? So, a minus 2 shifted it right to. Your numbers inside the absolute value, you'll always go the opposite, because this looks like it's going to go left. It's always going to go opposite. A negative number in here is going to shift you right. A positive number in here is going to shift you left. You always do the opposite of what's in those absolute values. So, the number outside the absolute value shifted us up and down. The number inside the absolute value shifted us opposite, but left and right. Very important. It's going to make graphing these go a lot faster. So now, I take a look at this first one. It says h of x equals absolute value x minus 1. Is the number inside or outside the absolute value? So how is that going to shift my graph? So, mentally, and we're going to write this out the first time, mentally, it helps to see what's going on. So the original graph looks like this. So now this is taking my graph down 1. There you go. So what is my new vertex? 0, negative 1. What is my domain? All the x's are still the domain. What's my range now? A little different. What's the lowest value? Right here. So now it's everything bigger than negative 1. There you go. So, shifted us down 1. Here's my new vertex. Domain hasn't changed, but my range did. Let's do this next one. Is the number inside or outside the absolute value? How is it going to affect? How is it going to shift the function? Left, 4. So again, mentally it helps. The original looks like this. Now I'm going to take the whole thing and go left 4. So now my vertex is -4, 0. My domain, it's still all the reals. I still have all the x values in play. It'll get there eventually. My range, the bottommost value is 0 on up, greater than or equal to 0. Any questions on vertex, shifting, left, right, vertex, domain, or range? So you're probably asking yourself, will they always look like this? And the answer is no. Next one. Pause this for a second. Remember we talked about this earlier this week, y equals mx plus b. What does this number do? What is this called? Very good. So, a number in front of the x gives me a slope. Same concept here. The number times the x is going to give me a slope. So, again, I'm putting the original down so you can kind of see a comparison. The original looks like this. So if I want to graph my new function, if I want to graph q, this gives me this has a slope of 1, up 1, right 1, up 1, right 1, up 1, right 1. So now my slope is 2 over 1. So that's going to take me up 2, right 1. Use the slope like we did Monday, Tuesday. Up 2, right 1. And this over here, this side is always just the opposite of this, so it's up, done. So that number in front has given me it's called a vertical stretch technically, but we use this slope to determine what's going on and then just make it a mere reflection over here. So now, my vertex hasn't changed, I'm still at 0, 0. My domain, I'm still at all reals. It's going to get there eventually, but it is still all real. And my range is y greater than or equal to 0. Let's do it again. So, again, number in front's going to give me my slope. Not going to put the original on here. I got a slope of -1/2. So that's down 1, right 2, down 1, right 2. I didn't shift that vertex. The other side is the opposite direction. So now I've got a graph that looks like this. The vertex is still at 0, 0, even though I'm upside down. My domain is still all real. My range, now I'm from here down. So my range is less than or equal to 0. So Numbers inside the absolute value are shifting you right and left, but opposite. Numbers outside the absolute value are shifting you up and down, and a number in front of the absolute value changes the slope of the right-hand side. Those are the big three things. That's more practice. That's tomorrow's notes. Good luck.